This video is going to talk about adding and subtracting and multiplying and dividing scientific notation. So I just want to review what you already know. We've already talked about in math that if I am going to be combining like terms, combining means I'm adding or subtracting, okay? If I combine like terms, then I keep my variable and I add my numbers. So this is 9x's plus 5x's. So that would end up being 14x's. So I keep my variable. This is just saying I have 9x's. X plus x plus x. 9 times 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, and I'm adding 5 more x's. 1, 2, 3, 4, and 5 more x's. So these are all just x. I can combine them all together, add them up, and I would have 14 x's. Okay, similarly right here, if I'm subtracting, if I have 6 x's, that's the same as x plus x plus x plus x plus x, 2, 3, 4, plus x. And if I subtract 3 of these, that would be 1, 2, 3. So I would just be left with 3 x's. I keep my variable and I just subtract my numbers. Okay, you also know that if there is not the same variable, you can't do this. Okay, I can't add 7 x's and 3 y's. These are different. So I have to just leave them like that. There's no way for me to combine these or subtract these, okay, because these are not the same. Now, I want you to think about that when we talk about adding and subtracting scientific notation. So this is my first number in scientific notation, and this is my second number in scientific notation. If I have the same power of 10, then these have the same place values. If I was to undo the scientific notation and write it in standard form, these would have the same place value. So I can add these or subtract these and it's not a problem. Okay, so 12 times 10 to the 4th power plus 5 times 10 to the 4th power, I'm still going to have 10 to the 4th power. Those are the same. And I'm just going to add 12 plus 5. So this ends up being 17 times 10 to the 4th power. So as long as my power of 10 is the same, I can add and subtract my first numbers and then keep my power of 10. But look at this problem. Is this written in scientific notation? Is my number between 1 and 10? And am I multiplying this by a power of 10? Well, I am multiplying by a power of 10, but this is not between 1 and 10. So in order to change this to scientific notation, I'm going to have to move my decimal. So if this is where my decimal is, and I move it one place to the left, that means that my exponent has to go up 1. It's going to increase by 1. So this ends up being 1.7 times 10 to the 5th. That's written in scientific notation, so I'm ready. I'm good to go. All right, let's try this one. If my first number is this and this is my second number, these are not in the same place value. If I was to line these up, 1.34 and 1.3, these are, again, I can add those, but they're not the same place value because this is going to have times 10. So I'm going to have more zeros on the end of my number, where this is only times 12. So I won't have as many zeros to hold that place value. So what I have to do in order to add these is I have to make sure these are the same. I can do that just by changing the second number. It could be either number for adding and subtracting. I'm just going to make it the smaller one larger. So if this is 12 and that's 14, I have to add 2 to my exponent here. And if I'm adding or increasing my exponent, then my decimal is going to move to the left. So this number ends up becoming this number with 10 to the 14th. Because if I move this number once, twice, see it once, twice, then this is where my decimal is going to be. But now at least I have the same powers of 10. So now all I have to do is add my numbers. So I'm just going to line this right up here. 1, 3, this would have a 0. So 0 plus 3 is 3. 4 plus 1 is 5. 3 plus 0 is 3. Put my decimal, and I have 1. So this is going to be my number between 1 and 10, and I keep my power of 10, which now they're both 10 to the 14th. So this right here would be my final answer, and I don't have to worry about changing anything because my final number in the front is between 1 and 10. All right, let's look at this one. All right, I don't have the same powers, so I need to make them both the same. These are negatives, so I need you to remember that the smaller the negative, the closer it is to 1. So in order to make these the same, I'm just going to add 1 to this. So now I have 10 to a negative 17th power, because if I have a negative 18 plus 1, that's a negative 17. And then because I added, this is going to move over 1 spot, and my new number is 0.314. Now that these have this same base 10, I can just add them. So I'm just going to come over here and write it 314. That's a 0 for a placeholder. 1 plus 0 is 1. 2 plus 4 is 6. This is 9. This ends up being 10. Carry the 1, and I have 10 point. 10.0961. Now, that's not in scientific notation. So I have to make sure that I fix this. So I do that. First, let's finish writing this. This is going to be 10 to a negative 17th power. In order to change this, I need to get my first number to be between 1 and 10. So I'm going to have to move this decimal to the left. Moving it to left, it is going to increase this by 1. So my final answer is 1.00961 times 10 to a negative 16. And that is going to be the answer. All right, so that's adding. The same thing goes when we are subtracting. So let's look at a couple of those, and then you can check your understanding. All right. Here is a subtraction problem. So these are not the same base. 10, they are base 10, not the same exponent. 7 is bigger than 4, so I need to increase this by 3. If I add 3, this is going to move over 1, 2, 3. So I'm going to have 2 zeros. And then 5, 5. Now this is 10 to the 7th. If I'm subtracting, I need to line these up so that I can subtract. You could also use a calculator. I've just been showing you because I feel like it's important that you know that we're talking about place value. So like on this, we're talking about the same place value. So I need to make sure those line up correctly. If I'm subtracting this, I've got to borrow from my 8, 7, 1. I'm just going to do this in the calculator really quick. 6.8 minus 0.0055. That ends up being 6.7945. I times that by my power 10 to the power of 7. This is between 1 and 10, so that is a good answer. All right. Go ahead and check your understanding and let me know if you have any questions.